So, first things we're going to do is we're going to calculate how far the ball has fallen. We're going to use this 16t squared as our distance. So we got 16t squared equals our distance. What was our t value we're going to use? Yeah, 8500. So let's plug in 8500. Let's square that to get our distance. 85 squared on a calculator is
7225.
okay, and let's multiply that by 16. 11 and 5600 feet. So before we do anything else, I always like to think reasonable or unreasonable that the top of the railing is 1.5 feet taller than a basketball hoop. Reasonable or unreasonable? Yeah, that seems fairly reasonable. Of course, what is some of the big reasons why that might not be perfectly accurate? The timing, right? The timing can be extremely flawed, right? But that's fairly reasonable, so we probably did a pretty good job, right? So let's talk about what we could do with this graph. So let's take this 16t squared and let's think about how we can apply it to a quadratic equation. So let's pull out our graphing calculators. I'm going to pull up our little Desmos, and we're going to look at what this looks like on a graph. So go to your y equals screen and type in 16 x squared, because x is our variable. In this case,
what do we type in?
16x squared. What do you think a reasonable window is going to be on this? Nicholas, give me a reasonable window for everybody to look at.
I guess X max 500.
Ooh, way smaller. Way smaller. Way smaller. Let's go single digits. How about we go 5 and -5? And then we go for y max min. Let's go 0 to, I don't know, 100. Okay? So you should end up with something that looks a little bit like this, right? Okay? So what we have is a nice little parabola. What did we say the height was at 8500ths?
Wait, what is the x max and min is?
So I went -3 to 3 for the x min, x max, and then for the y min, y max, I went 0 to 100. You might want to put like -1 to see it cross at the origin. And the reason is, what does the y stand for here? What are we talking about when dropping something? So yeah, the height that we're dropping it from. So what you can do is a couple different things. You can go on your trace feature, but let's go to 8500ths for our x value. Is 8500ths about 11?
Yeah.
Yeah, it's like right there, right? Why does it keep going? There it is. So yeah, right there, about 11. So we did a pretty good job with that. What if the time was, I don't know, 5 times longer? Okay, so we're looking at like 4 seconds. Okay, what's the height going to be if it falls for 4 seconds? How many feet? Yeah, about 256, right? Why is that? Because we are squaring it, so it's going up at a much higher rate. You know, it's not linear, things like that. So what do you think would happen? Okay, so here's a good question. Let's think, we're dealing with quadratics here, right? What do you think would happen if we threw it up? We threw it up. Let's talk about what that equation would look like. What would that look like if we threw threw something into the air. Think quadratic equations.
Well, would you need like some measurement of the force that you use?
Yeah, you need to know what your initial velocity would be, right? So what do our normal quadratic equations look like? What do we normally see? Give me like an example of a normal one. Go ahead.
0 equals x squared plus 10x
Perfect.
5.
Okay? So let's think about throwing something into the air. Think about throwing something into the air. What does the 5 represent?
Oh, the intercept?
The intercept, the y-intercept, yeah. So if we're talking about throwing something into the air, the 5 is the y-intercept. What does the 5 represent? Not exactly how far you threw it up.
Or where you started from.
Where you started, yeah, that's where you started. Okay? And so I'm going to throw a 16 here just because that's how far things fall. What do you think the 10 represents then? What's the only other factor in this case? Ben sort of mentioned it already. Initial velocity. Yeah. This is the speed which we throw. So we call that v sub t, initial velocity, which is not what you'll ever, you might see it on one of your packets, but so that's our initial velocity. When we have class again, which is not going to be Friday, it's going to be Monday, we'll throw things up. Okay? We'll know time, we'll know where we started from, but we'll be able to calculate how fast someone threw something, which I think is pretty cool. Don't you think that's cool?
Oh, wait, so if you don't have the 10x, that means you didn't throw it up?
No, so if this whole term was gone,
Yeah.
you wouldn't have it. No. So what you're saying is, what is the distance if you drop something from 5 feet?
Yeah.
Okay, yeah. So having this middle term or the v value is assuming that you threw it up.
Yeah.
Okay? Great question. All right, so what we're going to do in the last few minutes of class is we're going to get you some work to get started on. You guys will continue working on this Thursday. And you guys have a fun homework assignment to work on as well. I think it's fun. It's difference of squares. I love difference of squares.